Assalamu alaikum viewers. Bismillahirrahmanirrahim. Hope you all are well. In previous video, I have explained types of matrices. Now, in this video, let's look at the exercise. Here we have question number 1. From the following matrices, identify unit matrix, row matrix, column matrix, and null matrix. So here we have some matrices, and from these we have to identify which is unit, row matrix, column matrix, and null matrix. So look at this first matrix. A is equal to, this one is square matrix of order 2 by 2. So here all entries are 0. So this matrix is null matrix. This matrix is null matrix. Now look at this. Here we have only one row. So this one is row matrix. The matrix which has only one row, that is called row matrix. So this one is called row matrix. Now look at this. The matrix which has only one column, that is called column matrix. So this one is column matrix. Now look at this. Here diagonal entries are 1 and other entries are 0. So this matrix is a unit matrix. Okay, this matrix is unit matrix and its order is 2 by 2. Now look here at this matrix. Here it is only one entry, that is 0. So this matrix is null matrix. And this matrix has only one column, so this one is column matrix. Okay, now come to question number 2. From the following matrices, identify square matrix, matrices, rectangular matrices, row matrices, column matrices, identity matrices, null matrices. Okay, now look at this. Here what we have in this matrix, we have 2 rows and 3 columns. So this one is rectangular matrix. This one is rectangular matrix. Now look at this one. Here it is only one column, so this one is column matrix. Here we have 2 rows and 2 columns, so this one is square matrix. Here look at this, its diagonal entries are 1 and other entries are 0. So this one is identity matrix. Here all entries are 0, so this is null matrix. Now look here we have only one column, so this one is column matrix. Now we have question number 3. From the following matrices, identify diagonal matrix, scalar and unit matrix. Now look at this. here we have A is equal to 4004. The definition of scalar matrix is that diagonal entries are same and non-zero, must be non-zero. So here diagonal entries are same and these are non-zero. So this matrix is scalar matrix. Now look at this. Here we have its diagonal entries are non-zero, but these are not same. So we can say it that this one is diagonal matrix. Now look at this one. Here we have diagonal entries are 1 and other are non-zero. So this one is unit matrix. Now look here, in this we have diagonal entries are 3 and 0. So this here we don't have same entries. So what we say, this one is diagonal matrix. Now look here, in this when we will solve this 5 minus 3 we will get 2 here, and this 1 plus 1 again we will get 2 here. So in diagonal entries are same and non-zero. So this one is scalar matrix. Now next we have question number 4. Find negative of matrices A and B. Here we have A matrix and here we have B matrix, and we have to find the negative of both matrices. So what to do? We have to multiply it with minus. When we will multiply it, it will come minus here, and we have to multiply all the entries with minus. So what we will get here? Minus 1, 0, and here it will become minus minus will become positive 1. Now again here we have to multiply this matrix with minus. So here it will become minus 3, minus minus will become plus 1, here minus 2, and here minus 1. Now next we have to find the transpose of the following matrices. Here we have A is equal to 0, 1, minus 2. What is the definition of transpose matrix? We have to change the row into column. So here how we can take the transpose? We have to write here AT, and here we have to write this column as row 0, 1, minus 2. So this is transpose of this matrix. Now next look here, we have this matrix. How we can write? Here we have to write small t, and we have to change the rows into columns. We will make this column into row here, change this column into row, and change this column also into row. So we will get 3 and 5. So this is a transpose of this matrix. Now next look at the question number 6. We have to verify that if A is equal to 1, 2, 0, 1, then A transpose of A, then we have to take again transpose is equal to original matrix A, that is A. Now we have to start taking its transpose. Start with left hand side. What is our left hand side? It's A, T and T. So first of all what we have to do, we have to solve this bracket. What we have in bracket, we have to take the transpose of A. What is the transpose? Change the columns into rows, and here we have 2 and 1. So this is the transpose of matrix A. Now again we have to take its transpose. Now again change the rows into columns. We will change this column into row. What we will get here? 1, 2, and here 0, 1. Now what we have next? We have to see what is A. A is, that is equal to A. Can you see here? It is equal to A. Here we have 1, here we have 1, here we have 2 and 2, here we have 0 and 0, here we have 1 and 1. So this one is equal to A, which is over right hand side. Hence left hand side is equal to right hand side.